In this video, we present preliminary findings of our analysis estimating the area of ignition of the Caldor Fire. The Caldor Fire started August 14, 2021 and burned for over 2 months before being contained. Due to its slow start and other fires in the area, an initial perimeter of the fire was not ascertained until August 17th, 3 days after the start. We begin our analysis using imagery sourced from the alertwildfire.org camera network. Of the 20+ alertwildfire.org cameras in the area, 11 captured footage of the fire within the first 10 hours of the start. We use footage from 4 of those cameras to triangulate the area of ignition. The 4 cameras we used were Mount Occam 1, Omo Ranch Road 1, Armstrong Lookout 1, and Red Corral Road 2. The first view of the fire was captured on Mount Occam 1 from the east. This camera was already in a position to capture the initial plume. The smoke column can be seen on the horizon at roughly 8:45 p.m. The second view of the fire was captured on Omo Ranch Road 1. This camera was rotated at 9:26 p.m. to capture the smoke column. Unfortunately, we were not able to triangulate the position of the plume due to the fact that these cameras captured footage from similar headings to the east. To triangulate an area of interest, we fast forward roughly 4 hours to just after 1 a.m. when 2 additional cameras captured footage of the plume. Starting with Armstrong Lookout 1 to the west, we see a zoomed-in view of the plume. We annotate the edges of the smoke column to work out the heading of the plume with respect to the camera. Moving on to Red Corral Road 2 from the south, we note the camera was rotated at 9:45 p.m. to view the fire and started capturing imagery of the plume around 11 p.m. We fast forward the camera footage to just after 1 a.m. to match the time of the imagery captured from Armstrong Lookout 1 and annotate the edges of the smoke column. We note the lack of focus of the footage adds some uncertainty to the plume estimation. However, if we rewind the footage back, the plume is still located within the annotated bounds. These 2 views enable us to triangulate the area below the plume just after 1 a.m., roughly 5 hours after the start. We refer to this area as the ensuing area of interest. Using the triangulated area as a starting point, we analyze the footage captured earlier. We focus on the imagery sourced from Omo Ranch Road 1 due to its proximity to the ensuing area of interest. We annotated the smoke column bounds to get an idea of where the fire was roughly 4 hours earlier. Viewing the annotation rays projected from the camera, we see them pointing in a direction adjacent to the ensuing area of interest. Getting a closer look at the topography of the region, we see the ensuing area of interest is located on a ridge. We also see that the earlier sighting from Omo Ranch Road 1 points to an area in the valley below that ridge. To get an idea of where the fire could have started, we performed a watershed calculation using the ensuing area of interest and topography of the region. We estimate the area of ignition using the intersection of the earlier sighting from Omo Ranch Road 1 and the watershed calculation. To reinforce our estimation, we simulated a fire ignition using Technosylva's Wildfire Analyst simulation software. Wildfire Analyst runs a series of simulations using the fuels and weather conditions from that moment in time. We see the fire simulation working its way up the watershed, eventually reaching the ensuing area of interest. The final result of the simulation is almost completely contained within the initial perimeter of the fire and is in agreement with the progression of the plume measurements collected from the alertwildfire.org camera imagery. In conclusion, using a series of analyses including calibrated imagery analysis, topographic examination, and wildfire modeling, we are able to calculate an estimated area of ignition for the Caldor Fire. Thanks for watching.